So strangely, the last video got cut off somewhere. What happens when you have a free program? So these answers did not show up. So this is the expanded solution. A couple things to be careful of. Make sure you don't split this up into natural log of 9x minus natural log of 2. Okay, I'm going to go ahead and do the last one here. Start out with, this is the exponent 1/3, so rewrite as 1/3. And then we're going to write natural log 3x squared over 2y, which you can split into natural log 3x squared minus natural log 2y. And then you just keep splitting these up. So this is natural log of 3 plus natural log of x squared, which we've done is 2 ln x minus ln 2 minus ln y. And you don't usually have to break them up that much, but in case you are going to go ahead and take the derivatives, the nice part is the derivative of any of these is a constant. Natural log of 2 is a number. Okay, the next ones are just going to show you some examples for the derivative rules of logs. These are at the bottom of your paper. I'm going to use this one. It's a little bit easier for me to write the space. So our property is to take the derivative of u over u. So u prime over u. So essentially the inside of the parentheses is your u. So u prime in this case would be 4x over u, which is 2x squared plus 1. So the derivative, h prime here, 4x over 2x squared plus 1. That's simple. Don't do silly algebra fouls, canceling out stuff. Just have the derivative there. So you follow your same rules here of any other derivatives. If I'm taking y prime, this is a product rule. So the first times the derivative of the second. So in this case, the derivative of x is 1 over x, plus the derivative of the first times the second. And so y prime would be 1 plus ln x. Natural log of x squared minus 4. Be helpful to rewrite as x squared minus 4 to the 1/2 first. And then change the log. You don't have to. It just makes the problem a lot easier. X squared minus 4. So now I can do my derivative. So y prime, half is along for the ride. U prime over u. U prime would be 2x. That's my u over u. So 2's cancel out. You get x over x squared minus 4. Half is gone. You will see some things with logs that they'll kind of regenerate back to themselves. Natural log of t over t is a quotient rule. Low d high minus high d low over low squared. So t, the derivative of that is 1 over t minus u, the derivative of that is 1 all over t squared. So we have, this is 1 minus natural log of t over t squared. These are pretty, actually easier formula than some of the chain rule problems that we've done. They get a little more complex as you go, but that's for the most part the gist of it. If you look on the back of the paper you take notes on, there's a few other examples from that I just took off of another website. And you may see different forms, but again, you're just looking for the u prime and the u. So this is our u. So u prime is 2 over u, which is 2x. So 2 over 2x reduces to 1 over x. A lot of times there's something that can reduce. The u here is x squared plus 1. So u prime is 2x over x squared plus 1. We did this one already. This one, if you can't tell, there's a 3 right there. So again, you can do this one as a chain rule problem, but it's the derivative of the inside is your 1 over x. So 3 ln x to the second times 1 over x. So that ends up being, if you're solving, 3 over x natural log of x squared. And you can still do tangent line problems. So find the equation of the tangent line, take the derivative, and then plug in your point. A line's a line. And then also this last example on here is implicit differentiation. And everywhere there is a y, when you take the derivative, you have to do a y prime. So you see the dy dx's. The only difference is we basically just have a new rule for taking derivatives. It's not any new rules of derivatives. Okay, so reviewing, going back again, derivative of, let's just say x, derivative of natural log is 1 over x, and the derivative of natural log of a chain is u prime over u, because it's 1 over u times u prime. Easier to do u prime over u.